Hello everybody, and welcome back to the Poor Man's Chemist. So, I want to start this video off by thanking everybody that subscribed to my channels and that watched my videos in 2019. 2020 is going to be a good year, people. It's going to be great. Anyway, what I want to start off with here is our test of the rubidium bromide, the suspected rubidium bromide. What I've done here is made up some sodium silicomolybdate solution. You can watch my other video to see how to do that. I did it exactly the same way as I did there. And so what I was thinking when I was thinking about this some more last night, we don't need to repeat the test with the sodium hexanitridocobaltate 3. I mean, that test just tells us there's either ammonium or alkali cations in there. We know that. I mean, that's not in doubt here. The experiment with the tetrabromide also isn't very telling because it will give a precipitate with potassium. But sodium silicomolybdate should only give us a potassium with ammonium, rubidium, or cesium. It should not give a precipitate with potassium. I know there's no ammonium ion in this because I calcined the living shit out of it. So what I'm going to do is dissolve this in a little bit of distilled water here. There we go. We want to keep it nice and concentrated. I'm still going to try the tellurium tetrabromide. I mean, you know, because, hey, dirubidium tellurium hexabromide. That sounds cool. Alright, so, put a little bit in here. Here we go, people. This is it. And there is nothing. Well, shit. Why is there nothing? Whoa! Well, that's not fun. I don't even care. I'm more concerned about this. Oh, wait! There it is! There it is! There's a precipitate in there! Ah, that is fucking great! That is great! Alright, I'm gonna let this sit here for a minute while I go get this cleaned up. Damn it, I wanted to use that sodium silicomolybdate for something else. That's like 5 grams of sodium molybdate just gone. Oh, there is absolutely a precipitate forming in there. Okay, it's a slow former. God damn it, that just kills me. All right. There's not a lot, though. That's interesting. Now, that could just be because it doesn't form as insoluble a precipitate as cesium does. That's possible. I'll tell you what, let's test our silicomolybdate here with cesium chloride just to make sure there's nothing wrong with it. A little bit we've got left here. That's okay, I don't care. Yep, nothing wrong with it. Ah, hell with it. Might as well add it to the stuff I've already got. Okay, well, like I said, I don't know that it is as insoluble as the cesium salt. I know that ammonium will give a precipitate with it, but ammonium and cesium are pretty similar in size. Rubidium is a little smaller. Hey, it gave us a precipitate. I'm calling that a positive test, man. I know it's hard to see in the camera because of the glare. Let me see if I can show you guys better here. I'm worried about it not focusing like it did in the last video. It seems to be acting up with that. And there you go. You can see it. So, I mean, there's a fair bit in there. It's not as dramatic as the cesium, but we got to precipitate. All right. Let's take this last precious bit of solution and not knock it over, and I will mix it with some tellurium tetrabromide and concentrated hydrobromic acid, and we will see if we get a precipitate there, just to add to our confidence. If we can do more than one thing to confirm it, then that's good. Okay, don't touch that crap. Okay. Oh, there it goes. Man, what is it? Is it just because it's cold this morning? Nothing wants to react? Or it was just too dilute? That is a problem with this test, is that the, the source of the ion that you're testing has to be pretty concentrated, and I did dilute that down a little bit. Well, I mean, there's a precipitate in here for sure. It's there. So, I mean, people, I'm calling this a positive test. I mean, to me, unless I can get some kind of evidence, well, I mean, as more time goes on, it seems like this is dropping more and more precipitate. So, there you go. That's it, man. To the limits of my ability to test without access to instrumentation, it appears that this has worked. It looks like what I got was indeed rubidium bromide. And if I wasn't so goddamn clumsy and constantly knocking shit over, I would have gotten a pretty decent yield of it too. So, I mean, I am open to challenges to this declaration. I mean, of course, peer review is what science is built upon, and I would love some of my peers to review the fuck out of it. But I mean, to the limits of what I've got, I'm calling the process a success. So, again, if you would like to dispute that, I am 100% open to that, because God knows I've probably overlooked something. But anyway, there you go, people. It looks like we have it. A way to convert cesium or rubidium chloride to cesium or rubidium hydroxide, and by that, any other simple cesium or rubidium salt. I mean, I think we've got it. I can't find a better way. I had thought that maybe, like with the perchlorates, but then when I started looking at the solubilities, man, there's not... Maybe, I mean, if you did it with like sodium perchlorate, or not perchlorate, I'm sorry, sodium chlorate. Rubidium chlorate is the least soluble of the alkali chlorates. I don't know if y'all knew that. Cesium is a close second. They are both way more insoluble than sodium or lithium chlorate, but not so much so potassium chlorate. You would get some pure rubidium chlorate out of a solution of potassium chlorate, but it would also leave you with a whole bunch of potassium and rubidium mixed together, and good luck separating that shit. So, anyway, yeah, we are getting some crystals here. Let me show you guys what I'm seeing. Got some nice, very nice little crystals in here, man. Those are beautiful. I mean, that's actually better than what I got before. And that tells me, if nothing else, man, the precipitating agent is pretty damn pure. Yeah. And then here we go with the silicomolybdate. See what I mean? It almost looks like it's dropping more precipitate as time goes on. So yes! 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 It fucking worked! It fucking worked! Yes! Oh, that is so fucking cool! God, I really wish I could confirm this with some kind of instrumental analysis. then, you know, I could really, really, you know, just rest assured it would silence any lingering doubts. But son of a bitch, people, I think we've got it. I think this is it. Yeah! Woohoo! All right, what an auspicious start to the new year. Fucking A. Well, let's hope that the next thing that we're about to do is just as successful, because I thought we could do a fun, neat experiment where we make a complex salt of thorium, much like we did with tellurium. Should be a quick and easy one, so let me clean up this and let me get that set up, and we will get started. Alright, everybody, here is the filtered and isolated rubidium silicomolybdate and dirubidium hexabromotellurate 4. So there we go. Isn't that nice? It's a nice yellow, nice orange color. I think that's absolutely beautiful. So anyway, let's move on to the experiments that I wanted to try today. They're very simple. Let me move you guys up here and zoom you out. And I am going to watch this fucking thing to make sure it stays in focus. I am really sorry about that on that last video, y'all. I had no idea it had gone out of focus for so long. Fucking piece of shit. Anywho, what I have here is 1/2 gram of thorium hydroxide that I made in the previous video. What I'm going to do is I'm going to mix this with a little distilled water here. Sorry you can't see that, although there's really nothing to see. Remember, it's totally insoluble, so I did was just add a little bit of water here to it. It's just distilled water. And we are going to put it on the stir plate here. And what I'm going to do is I'm going to add concentrated hydrochloric acid to this very carefully, drop-wise, so that I can try to get it to as close as possible, just a solution of, or slightly acidic solution of thorium tetrachloride. Then I'm going to filter that, and we are going to try combining that with a 3.3 molar solution, that's my stock solution, of cesium chloride, and see if we cannot get a complex salt here. According to Atomistry, these salts do exist, but they're difficult to get them to precipitate. They're very hygroscopic, so I mean, I don't know. We'll see. We may have to boil that one down in order to get a solid. But it also isn't very clear. I mean, that's one sentence on one website. So, I mean, maybe if we keep the concentration very high, we can get it to work. We're also going to do a bonus experiment, because in the all-important checking of the literature right before doing the experiment, I was perusing around, just kind of looking at the other thorium compounds on Atomistry. I can't talk. Nothing unusual there. And I came across a reference to thorium superoxide, which, as it happens, is made by combining the hydroxide with hydrogen peroxide. So, I am happy to use a little bit of my dwindling stocks of 35% hydrogen peroxide to give that puppy a try, and, you know, hey, I don't know that anybody else has done that in another video. Don't quote me on that, but, I mean, it should be a fairly unusual compound. So, anyway, let's get started with this first one. I'm going to get out concentrated hydrochloric acid here. And again, I mean, it's going to end up being acid overall when we're done, because we've got to go past the end point. But we don't want it to be too acid. Let's see what that gets us. It's not fizzing or doing much of anything, really. There we go. I do believe something is starting to happen. I'll zoom you in, although, and you aren't missing anything. It's just very quietly dissolving. No drama. Getting a nice, slightly yellowish tinge to it. Man, it's crystal clear. I don't know that it needs to be filtered. Cool. Well, that'd save a couple minutes. Staying focused, you piece of shit. Yeah, I don't know that this is going to need to be filtered. It's looking really clear. Well, that's awesome, because I was going to use one of my rapidly dwindling supply of micropore filters. So it'd be nice if I didn't have to use one. Also shows me making that thorium hydroxide was a nice bit of work, if I do say so myself. And I do. Then again, it's probably, realistically, pretty hard to fuck up making thorium hydroxide. I'm sure somebody out there could do it, though. Hell, I'm sure I could do it. We all know about my lack of patience. Alright, so here we go. I mean, not in this case, though. It really is. Here, see? Well. Beautiful. Alright. Now, I should probably calculate how much of this stuff to add. That might be a good idea. Okay, so I've done the math, and if we're going to go for what would be the complex salt of thorium tetrachloride with 3 units of cesium chloride, then we're going to need 1.51 milliliters of this solution, of the cesium chloride solution. So, let me measure that out. This is just an approximation, because, we're not writing a paper here. Okay, can you see? I want to make sure you guys can see all the action. Okay. No precipitation. Well, it does look a little weird. What I'll do is I will put this on the hot plate and I will let it evaporate down over low heat, and we will see what we get. Alright everyone, I thought this was interesting. As the solution is reducing down here, this is our mixture of thorium chloride and cesium chloride, it's taking on a distinct yellow color. Like, that's almost as vivid a yellow as silicomolybdate. And I just scrubbed this beaker with like soap, water, a scrub brush. It's not contaminated with anything. So this is kind of interesting. Anywho, let's move on to thorium superoxide. So what I've got here is a suspension of thorium hydroxide in water that I've had stirring here for a little bit to break it up. And what I'm going to do now is add 35% hydrogen peroxide after I turn this around so you guys can see it without the thing in the way there. And make sure the damn thing is focused. Okay, here we go. As to what's going to... Oh, I was going to say, as to what's going to happen, your guess is as good as mine, but I guess that's what's going to happen. Oh, I should also mention that I've been heating this here for a little bit. Now, according to atomistry... You know what? Actually, let me turn off the heat. Since I don't really know if that does anything. Atomistry says that this product is, and again, we know this is a very dated source, but that this is like a true superoxide. So in other words, it completely adds the elements of hydrogen peroxide to thorium. Then according to atomistry, it says that it is subsequently hydrolyzed into what looked like a diaquo dihydroxo and an monoaquo trihydroxo complex, which, okay. I should also point out that if we had made this stuff by combining thorium acetate or thorium sulfate and hydrogen peroxide and added ammonia to it, it would have given us an unstable form of thorium superoxide, which, according to atomistry again, breaks down into thorium trioxide. I thought that was interesting also. Holy shit, you guys, check this out. It's a yellow solid. That is so cool. Look at that. This is, well, theoretically, I guess it would be tricesium heptachlorothorium 4. That is so fucking amazing. Look at that shit. That is so cool. Oh my god, that is so cool. Oh, wow. I'm going to have to keep very carefully evaporating this down, but look at that. That's it. God, that is so neat. And then check this shit out, too. Oh, of course, there it is. There is the superoxide. It wasn't perfectly dry when I put it in there. But, yeah, that's it. Turn it here. Well, god damn it, of course, the fucking water is gonna frost up the glass, but you can see what it looks like down in there. So, that's it. Check it out. We did 2 thorium compounds, everybody. Oh, man, check. That's cool as fuck. It's still evaporating. Ah, that is great. That is great. Oh, yeah. Oh, okay, it's done evaporating. That's it. That's it. That yellow solid. That is it. Oh my god, we did it. We made an addition compound of cesium chloride and thorium chloride. That is the shit. Ah, that is great. Oh, that is so cool. Oh, man. That is awesome. Well, we just had all kinds of unusual compounds in this video. Oh, well, I'm going to close it out with that, people. That is so goddamn excellent. Anyway, if you liked the video, give it a thumbs up. If you didn't like it, give it a thumbs down. Subscribe, share the video, comments, please. I love hearing your thoughts. And until the next one, y'all, I will see you later. God, that is so fucking cool.